So we've just talked about this idea of work as being associated with an interaction, and work as being the amount of energy that's transferred, that's actually done. The amount of work that is done by an interaction is actually the amount of energy that's transferred from one part of the system to another part of the system, or from the rest of the universe to the rest of the universe by that interaction. And we introduced this idea that you can calculate that by integrating the force over distance, and then did some sort of simple examples of looking at what the work is that I would do on an object, what the work is that friction would do on an object, and so on as I moved the object. I thought it was worth taking just a little bit more time on that and tying it back to this spring example that we did earlier, and sort of thinking about this spring example from a work perspective. So we could ask the question, what's actually going on work-wise at each of these keyframes, right? So you've got keyframe 1, 2, 3, and 4. So in keyframe 1, the mass is stationary, right? And to the extent that the mass is stationary, the mass is not doing any work on anything, and the spring is not doing any work on anything, right? You've got a force that's acting, right? If I draw the free body diagram for the mass at this point, right, the free body diagram includes a force that's due to the spring, but at this point, no work has been done yet because the mass has not been displaced through any distance, right? Now, at this point, you've got a force that the spring is applying to the mass that's in that direction, and the mass has been moved some distance, right? So at this point, you would say the spring has done some work on the mass, right? And that is why, in fact, the energy of the spring has dropped, right? The energy stored in the potential energy of the spring has dropped. That's been transferred to the kinetic energy of the mass, and so work has been done on the mass, which has resulted in the mass's kinetic energy going up, right? At this point in time, you've actually, throughout this sort of first half of the cycle, the spring has been doing energy on the mass. So up until that point, right, from here to here, right, or from this point to the point where the mass is in the middle, the spring is doing work on the mass, right? And then from time 3 on to time 4, when the spring is actually being compressed, now if you think about it, the spring is actually applying a force that's in that direction, while the displacement is in that direction. So F dot dx, the force of the spring, dot dx is less than 0 for timestamp 3, whereas for timestamp 2, F dot dx is less than 0 between time 3 and time 4. But the force of the spring dot dx is greater than 0 for these earlier times. So once the mass moves past this center point, now the spring is no longer actually doing work, or it's doing negative work. Rather, the mass is doing work on the spring, right? So during this time, the mass does work on the spring. And so you can see that work in this context, the work that's done by the spring, is actually the transfer of energy from potential energy to kinetic energy, and vice versa here, from kinetic energy back to potential energy.